Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 2 in the cross-site scripting module titled Stored XSS into HTML Context with Nothing Encoded. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsrigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on cross-site scripting labs, and select lab number 2 titled Stored XSS into HTML Context with Nothing Encoded. Alright, let's get started. This lab contains a stored cross-site scripting vulnerability in the comment functionality. To solve this lab, submit a comment that calls the alert function when the blog post is viewed. So the target goal over here is to exploit the stored cross-site scripting vulnerability in the comment functionality and call the alert function. Okay, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Alright, so for cross-site scripting vulnerabilities, what we're looking for is client-supplied input that is reflected or stored in the application and then reflected back to the user. So if we click on View Post right over here, you could see that you're allowed to add comments to the post, and the comments get displayed back to you under the post. And so over here, if the application does not properly validate input and encode it on output, then it could potentially be vulnerable to a stored cross-site scripting vulnerability. And this is much worse than a reflected one because all you have to do is enter your XSS exploit in whatever field that is vulnerable, and then anyone that visits this post over here, that XSS exploit will run in their browser, and then depending on what malicious action that XSS exploit does, it could have severe impact on the entire application itself. And so with reflected XSS, you would have to send a phishing link to a user, but with stored XSS, all you have to do is put it in the application. It gets stored, and anyone that visits this post, it will execute for the user. So the first thing we're going to do is see if the comment functionality is vulnerable. So we'll enter proper input first and see which ones are reflected back to us. So let's say test.ca, and then the website will say http test.ca, post comment, and then we'll visit the blog again. And you could see our comment is entered over here. So we've got the comment field is reflected back to us, and then the name field is reflected back to us. Also, the href element, so the link that we put for the website, could also potentially be vulnerable to cross-site scripting. So we'll start off with testing the comment field and see if it's vulnerable. So we'll add our classic cross-site scripting payload, script alert 1, and then we'll close this script tag. All this does is call the alert function, which outputs a window that contains the string that is inputted in the alert function, which in this case is just 1. So let's put test and then test at test.ca, and then let's say the website is http www.test.ca. Now, if the input is properly encoded and validated in the backend, what happens is that this is viewed as a literal string instead of as part of the client-side code. If we do get an alert, that means it is interacting with the JavaScript and it is being viewed as JavaScript, and therefore it calls the alert function. So let's click on post comment. And we already get the congratulations, you solved the lab message, and so we know that we've successfully exploited the XSS vulnerability. But if we go back to the blog, we should see an alert box, and we do. So you can see over here, there's an alert box that contains our string. Click OK. If you go back over here, notice that the comment is not even displayed because it is seen as part of the client-side code, and so it was executed as client-side code. And we could see that in the response of the request over here. So if we look for the alert function, you could see that it's literally viewed as client-side code instead of as a string, and therefore the application is vulnerable to an XSS vulnerability. All right, so we successfully completed the exercise by exploiting the stored XSS vulnerability. In the next lab, we'll look at another case of a cross-site scripting vulnerability.